function declaration, declare a function. So here function return function name parenthesis is a function parameters, so semicolon. This is the function declaration. So that means, so we should have a name, function name, and the function parameters. This can be void, that means empty. You don't want to, if you don't want to send any parameters to the function, you can leave it as void, or you can have any data type, integer, character, float, and double. So any parameters, or you can leave it empty. And in the function name, function return, the same. Either you can leave it void, or you can use any data types. Int, character, float, int, character, float, double. You can have any data type or leave it empty. So this is called function declaration. Okay. Then we will have a function definition. Here you can have again the same function return function name, function parameter, and it depends, it remains same. It can be any data type or make it empty. This is also you can do empty, or you can make it any data type, and the function name of your choice. And this should be same. This line and this line should be same, apart from this semicolon. Need not to add semicolon here. Apart from that, the function return, function name, and function parameter remain same. Open the parenthesis here. Here you need to write function body. This is the function body. That means you will have the code here, actual code, in the close bracket. So remember, no need to add semicolon here. So in the function body, you can process, you can use the function parameters and process them and return function. And here you can return whatever function return, if there are any. This is again a optional. This is, if this is void, then you can return 0 or 1 here, to notify whether function is success or failure. You can return 0 or 1 if there are no function returns. If there are function returns, then you can return with the value, or you can return empty here. And the function parameters, this function body will process the function parameters if there are any. Otherwise, it will have its own code. It may not use function parameter and process and return the value based on the implementation. So this is function declaration, the first. Then the function return, function definition, function declaration, and last one is using the function, maybe in the main function, close, and you call function here. Say for example, int a is equal to function name, function parameter are void right here and semicolon. So here in the function, in the main function, you call the function. Whenever you call this function along with function parameter, if there are any, otherwise with a void you call it, and this function will be called. Okay, and this guy will execute the function body and returns void or function. It may be function return or maybe void, that means 0 or 1 you return, or it returns nothing, just return. Instead of, in case of void, it return semicolon, nothing will be returned here. So in case of it, if it returning anything, here in this example I am returning integer, so this guy may be returning some value based on the requirement, and this return value will be stored in the A, some variable in the main, and this variable can be used for based on your requirement, this can be used. So this is how we can store the return value of function and store it here and use. Okay. Okay. Say for example, we have a main function return. Now you write a code here and you want to execute this code many times, multiple times in this segment. Say this is the block one. The same code you need to execute multiple times. So like this, maybe let's say for example 4 times, 5 times, or 100 of times, depending on the requirement. So instead of writing this code multiple times, we write one time here and call this function how many times you want here, something like this. The same function will be called here whenever the CPU execute this processor, it calls function, this executes and returns here, then it executes and executes this function and comes back here, then it calls third time. The third time it goes here, the processor will go here and execute this the code here, then returns. So like this you can call any number of times, and if you observe, the function is implemented only once. Maybe this may be 50 lines of code, or maybe 1000 LOC, any number, maybe 5000, maybe 1000 times, 1000 lines of code that you can write only once and call as many time you want from the main. So this is the advantage of function. Okay, say for example the disadvantage, maybe you return a small code, maybe 3-line code here, simple function, 3-line of code, and you are calling here from here. So whenever the main calls the function 1, it comes here the function call, here function invoking, then the function return. Just to call 3 lines of code, function call is there, invoking is there, then executing the function, then returning from here. So along with 3 lines of code, you have extra function call and function invoking and function return, 3 instruction extra. It may be multiple instruction. Here, just for the simplicity, we call each as a instructions, one instruction, function call, function invoking and function return, 3 instruction extra will be added. So instead of that, implement this 3 line of code directly here and just call directly from the main. Just execute this 3 line of code directly from the function call. So in this way, for the small function, the function call and invoking and return will be override. So simple functions can be implemented directly in the main instead of making them as a functions. So that is where the disadvantage of function will be there. Small functions, small instructions, better to use direct execute the instruction in the main. If it is a functions of bigger length, more than 50 line of code, 100 line of code, like this, then implement the function. This way the function will be you will get advantage of function. So this is the example. You can observe I already discussed about this. That was handwritten. So this is computer typed. You can see the how we can have the function name, function declaration, that means function creation, then the function definition, and that means function body, how can create a function body, then use the function, that means function calling here, like this, sending the function parameter. So this is the example how we can use functions in 3 different classes. Okay, here one example, a real-time example. Say this function, my function, will be receiving 2 integers and return integers. Okay, return type also integer, and receives 2 integer as a parameters. So here I return, you can observe I have written only int and int here, but in the function definition you can see I have written int a and int b. This a and b can be omitted here in the function declaration, or you can add. Both are valid. Adding a and b variable here in the function declaration also valid, or you can avoid adding it. Both are valid, no problem. In the function definition, so I have written my function int a and int b as a receiving the function parameters, and this is int is a return type. Okay, and this is the function code where I have declared int c. C is equal to a plus b. I am adding this a and b, a plus b here to the c and returning c. So c will be written as int to the. So here this is the main function. In the main function, I am calling the my function 6 and 4. Whenever you call my function with 6 and 4, 6 will be assigned to a and 4 will be assigned to b. So this 6 and 4 will be added here, 6 plus 4, and will be copied to c and returning c. So c will be 10 here. So this returns c, that is 10. 10 will be assigned to sum here, and printing the sum here in the sum one is equal to sum I am printing. So you can see in the output sum is printed 10. And the second function I am calling, same function I am calling with 20 and 8. 20 will be assigned to a and 8 will be assigned to b. 20 and b, 20 plus 8 will be 28. 28 will be copied to c, and c is returned and copied here to sum. And I am printing the sum here. Sum 2 is equal to printing sum. So you can see sum 2 is printed 28 as expected, and I am ending the main function. So this is the one simple basic example how function can be declared, defined and used. Yeah, we'll move on to the next example where so I have, you can see here, so this is about the scope of a variable. So I have declared one integer x is equal to 5 inside the my function, That means this variable is a local variable that belongs to my function. So that means this 5 can be accessed only inside my function. This inside this flower brackets. Outside the flower bracket, this x is not available. That means if you go to main and you declare if you're calling a my function will be called, and it does nothing. It returns here, and you try to print x here. So you can see in the output in function main, x is undeclared. That means in the function main. So this is the function main. In the function main, the x is undefined because in the main you cannot see any declaration for the x. Declaration is available to the my function. So this x is available only to this flower bracket. Inside the flower bracket is not available in this block. This is one block. This is second block. So whatever you declared inside the block is available only to this block, and here x is declared inside this block, so it's available only for this. Okay, this is about the scope. Let's move on to the next example. You can see here, so this global variable is created outside the main, outside of all function. That means this x is not inside this block or not inside this main also. Is outside the all block. Whenever you declare x outside the all block, this will have global scope. That means this is called global variable. That means this 5 is available for this block also and for this block also. Also all the function in this file can be accessed this x. So you can observe here in the main I'm having int a, and this is a local variable here. This int a is local variable and this cannot be used outside the main function. This is available only to the main function, and this I'm calling my function here. So whenever I call my function, I'm trying to print x. X will be printed as it is, the 5, and I'm changing x to x plus plus. That means x now becomes 6 and printing x here. Now you can see the output, x is printed 6. So and this guy will return to the main function, and in the main I'm trying to print x again. It prints 6. That means whatever the print x is modified here, that is available to main function, and this x is printed 6. You can see here the x is printed as 6. Okay, this is about the global variable. Let's move on to the next example. Here some of the functions are available. Standard library, you can say standard library math will be available. So some functions are already implemented in the math file, so that can be accessed. That math library can be accessed when you include math.h. So this, whenever you include math function, you must include math.h, and you can use all the math functions. Some example of math functions are square root. So printf square root of 16 is printed as 4. I'm trying to round a number here. Seal and float. Whenever you seal is trying to round it to the nearest integer, but at the upward direction. So 1.4 upward direction is 1. So upward direction means the next integer 1.4, the next number is 2. So 2 is printed, and this 1.4 is, this is rounded downward. Downward means 1.4 is downward is 1, so it's printed 1 here. And so this is about square root, seal and floor functions. Last one more function is POW, that means it's a power x to the power y. So whenever you pass two parameter here, power 4 comma 3, that means 4 to the power 3. So 4 to the power of 3 means 64, so it's printed here 64. Let's move on to the last example here. So this is an example about we discuss about the inline function here, how inline function works. What is inline function? So whenever you include inline keyword here, inline, so whatever implementation is available inside this directly inlined. That means this code is actually inserted here, and whenever you compile, this x into x is actually replaced square of 5, and directly x star x will be implemented here in this square. Instead of function calling, this will be added as direct code. Directly this x into x will be inserted here. So this is called inline. Whenever you have a small functions, small very few line of codes is available, so this function can be, you can make it inline explicitly by mentioning, and this square of 5 will be replaced with x into x, and function call and function return will be avoided. Directly it executed, this code got executed here, and it prints. So here in this case, square of 5 is 25, and this 25 is printed here in the output. So some advantages. So inline function, you might see the inline function used. Small function that asks the compiler to insert its code directly where it is called instead of calling it. So this will make a little faster, because function call and function return is avoided. Directly the code will be inserted here, so it will be more faster. So some information is given for the inline function. So this will, whenever the functions are very small, you can use it. So too many inline function may make, say for example, if you are calling square many times here, this code will be inserted that many times, and this code may become bigger, and that problem known as code bloat. Yeah. So this is about the function. Thank you. In this example, we discuss about the function recursion. So where you can see here we are declared and defined example, a function that adds two numbers. The whatever you pass as k and the previous number of k will be added. So like this it will add and it will call itself. So you can see here the sum is calling this function. When k is equal to greater than 0, the return will do k plus sum again. This sum is calls again the sum function itself. That means function calling itself. Int k, again if k is not equal to 0, greater than 0, then it calls again k plus sum of k minus 1. Like this guy will call till k is greater than 0. When k becomes 0, then it returns to this function sum. So started with 10 and it go up to 0. So as you can see the explanation, first it goes with 10 plus sum 9 and it calls again sum. This whenever you call sum 9 plus sum 8 will happen. Then sum 8 plus sum 7, like this it will call up to 0. Then 10 plus 9 plus up to 1 it will be added. So you will get a result 55. You can see in the output. So this is the recursion basic example for you. Yeah, maybe it may feel little difficult to understand in one go. You may need to practice it, and you may need to repeat multiple times and implement and do some more example of simple recursion functions. Then you will get some idea. Okay, let's move on to the next example. Here you can see the function pointer. It's like a normal pointer, but it points to a function. This means it stores the address of a function, allowing you to call that function using that pointer. Okay, so this is the declaring a function pointer here. So return type, the pointer name, and the function parameters, type 1, type 2, and for example you can see return type is integer, and this is a pointer to function. You can see the parenthesis around the star pointer is important, and 2 parameters integer it will receive. And here you can see the pointer is declared. You need to assign the function pointer to this pointer, the pointer to a function. Okay, both are valid here in this line. You can see pointer is equal to add, pointer is equal to ampersand add. Both are valid. And you need to call that function like this. The pointer, using a pointer 5, 3 or star pointer parenthesis 5, 3. These both are valid. This way you can call the function. So declaring a function, and declaring a pointer, and assign the pointer, function pointer, then you can do function calling. So there are 4 different categories required for the function pointer to be used. Here you can see a pointer to a function with a real-time example where I have defined add int a comma int b. The function is declared here, and defining a function so that this receives 2 integer a and b and adds and returns a plus b. Okay, and here you can see the pointer is declared here for a pointer function pointer with a 2 int receiving and returns int, and this is the assignment of address of function to a function pointer, ampersand address to a pointer. Okay, and here we are going to call the function using function pointer. So this is the function pointer 5, 3. So we are passing it to the this add function. So whenever you say pointer 5, 3, so pointer will go to the address here add. Okay, so add here, and it takes 2 integer as input 5, 3 and adds 5, 3 5 plus 3 and returns 5 plus 3. That means 8 is returned here, and 8 assigned to result, and result is printed here. So you can see in the output the result is 8. Let's move on to the next example. So here we will pass a function as an argument. So the function name itself, say for example greeting morning or greeting evening, we are passing here as a function argument, greeting morning and greeting. So this guy will receive the function pointer as an argument. The greet function will receive the function pointer as an argument, and it calls that function. So whenever you call greet morning, so this greet will be invoked, this greet, and this is the argument. This function pointer will be assigned with greet morning, and this function will be called here. That means greet morning will be called. So here we have a print of good morning. Same way, so greet evening will be called, and it calls the greet evening here. It comes here and prints good evening. So you can see the output, it printed good evening, good morning and good evening. So this way you can pass the function pointer as an argument. So this is one more advantage of function pointer. You can pass function as a function argument. Okay, so here greet takes another function as a parameter and calls it. This is commonly used in event driven program libraries and that need user provided callback function. So this callback function is an important feature of C. So in the function, so maybe whenever you get a chance, we will try to understand in more elaborated way what is callback functions. So this example will give you basic idea how to use this callback functions. So especially for event driven program or maybe for the libraries. Okay, here you can see the function pointer array. So so far we learned about the function pointer. This is a function pointer array where we'll have multiple functions as an array in the function pointer. So we have a function pointer of array of function pointers. So three. So this function point assigned with add, subtract and multiply. Add, subtract and multiply. So this is the usage. So whenever you call each index 0, 1 and 2. So this add is 0, 1 and 2. So these three index will be called using a map, using a loop. Okay, 0, 1, 2. So whenever you call 0, it invokes add function prints add, subtract function prints subtract, multiply function prints multiply. So all the three operations will be called here, add, subtract, multiply, and it prints respectively. Okay. So the difference between normal function and function pointer is normal function called directly by its name. The function is decided before the program runs, good for simple code. So whereas the function pointer called using a pointer, you can choose which function to call while program is running. This is very important. So the function you can call during the program is running. Okay, not like this is decided before the program runs, but this call will happen whenever the program is running. That time you can decide which function to call. So runtime you can change the function call. Good for flexible and reusable code. Okay, this is about the function pointer and function callbacks. Thank you.